question session. In that one among a mixture of gas contains hydrogen and oxygen gases in the ratio of 1 is to 4, that is weight by weight. Okay, what is the molar ratio of two gases in the mixture? Options they have given. I hope you got an idea. Last class also we were talking about this kind of sums. Yes. Come on, let us go for it. So N of H2 is to N of oxygen. So in that way, 1 by 2 hydrogen, right? 1 by 2, what is the ratio they have mentioned? 1 is to 4, right? So that means 4 by 32. Right. Okay, we can simplify this further. Here what you will get it? 8. So 2 is to 8. Let us go for LCM. 2 and 8. So what you will get it? 2 into 2 into 2. You will get 8. So 2 is to 8, if you are going for that to make it a ratio, you will get 4 is to 1. So what is the exact answer for this? B is the correct option. Hope you got an idea. Suppose if you are getting such kind of sums, you just go for that idea as you are learning in that way simplification. This is a simple and easiest way to solve the problem. This is not so high. This is very simple and easiest one, and this is also one of the competitive based questions. I would like to give you all competitive based questions only. Yes, come on, let us go for the next question. The next question, it's very simple. The combustion of methane expressed as CH4 plus oxygen, it gives CO2 plus 2H2O. The number of moles of methane required to produce 11 gram of carbon dioxide after the combustion. So number of moles they are asking in the question. Come on, let us go for the options they have given. See, number of moles, you know the formula. What is it? Number of moles, how to identify? Given mass by molecular mass. That's all. So number of moles of carbon dioxide. So number of moles of carbon dioxide. So given mass already they have given 11 divided by what is the molecular mass of carbon dioxide? It's 44 gram per mole. Right? So 44. So what is the answer you will get? 0.025. So the option it is C. I hope you got an idea. These are all very simple questions. Come on, let us go for another one more important questions. This is also based on the competitive question only. Now the next question. Suppose the element X and Y combine to form two compounds. They are XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 moles of X3Y2 weighs 9 gram. So, what is the atomic weight of X and Y? Generally, the question will be asked, what is the number of moles only? So, given mass by molecular mass, that will be very easy. And even they will mention the what it is element also, that easily we can identify the atomic mass, atomic number, everything. But here number of moles they have provided, you have to find out the atomic weight, and that too they mention X and Y. So it will be very easy if you find some tricks. Okay, now let us consider small x and small y, or the atomic weight of capital X and capital Y. Okay, now first and foremost, they have given the number of moles. No, what is that number of moles? 0.1 mole of XY2 weighs 10 gram and 0.05 moles of X3Y2 weighs 9 gram. Okay, let us go and identify that. Okay, now here 0.1 mole of XY2 weigh, that is 10 gram, right? Okay, now X plus 2y equal to 10. That is a given mass divided by number of moles equal to how much? 100 gram. That is combined together. That is atomic mass. The same way 0.05 mole of X3 Y2 weigh, it's 9 gram, right? So the same way 3x plus 2y equal to here 9 by 0.05. So what is the answer you will get? 180 gram. So this is equation 1 and this is equation 2. Okay, now let us go and apply the value of x. X equal to 100 minus 2y. We can take this equation. The same equation only this is x plus 2y equal to 100. So x equal to 100 minus 2y. So this equation you can substitute for that second equation. So how to apply that second equation? 3x plus 2y equal to 180. So 3x, capital X, right? So 3x plus 2y equal to 180. So you just apply that 3, substitute this value. Substitute this equation in 2. Okay, so 3 into 100. 100 minus 3. That 2y plus here 2y equal to 180. Right? You just apply this value into this. Okay, that means here what you will get it 300 minus 2 3s are 6y plus 2y equal to 180. So when we are going for that y value, if you are going for it, actually as you are calculating you will get 30. So y value you got, this is 30. Now x value you have to identify. X value the same point only. Here what it is, y value you have to apply the same equation. 100 minus 2 into 30, right? So 100 minus 60 equal to 40. So x value it is 40 and the y value, what is this y value? 30. So what is the answer here? Option they have given here 40 30. Option A, it is the correct answer. I hope you got a clear idea about that. How do we find out this answer? Small trick only. So atomic weight of A and B, that is X and Y. Here they mentioned X, Y and Y, no, not A and B, X and Y. So this is X and this is Y. So first and foremost, already they have given what it is, number of moles. From number of moles, you are finding out that atomic weight of combined. This is a combined X, Y2. Okay, this is XY2. So this is one answer. And the second one, this is the other answer. Now, each one we are applying the value to get that idea. We are using some tricks. I hope you got a clear idea about this question. And this is very important question. Okay, come on, let us go for the next question. The next question, it's very simple and interesting also. The mass and charge of 1 mole of electron respectively. So mass and charge, they have given the option. And it is very easy also. See here, the mass. First let us go and identify the mass. Okay, mass of 1 mole of electron. So how much it is mass of 1 mole of electron? Here actually 9.1 into 10 to the power of minus 31 into Avogadro number. 1 mole of electron, right? So 6.023 into 10 to the power of 23 kg, right? So what is the answer? You will get it here 5.48 into 10 to the power of minus 7 kg, right? So this is the mass of 1 mole of electron. Now the second one, charge. The charge of 1 mole of electron. So what is the charge of 1 mole of electron? Here one, here 1 Faraday, right? Charge of 1 mole of electron, 1 Faraday. So 1 Faraday, it is 96,500 coulomb. So 96,500 coulomb, how can you write it? 9.65 into 10 to the power of 4 coulomb, right? Okay, now this is the second answer. Now respectively they have mentioned, so the first option, it is 54 point, yes, it's wrong. Here kg they mentioned, but 54, 5.48 only. So this is also wrong. This is 3 it has mentioned, it is 4 actually. Yes. Now 5.48 into 10 to the power of minus 7 gram they mentioned, it's kg. So, which is the correct option? D is the correct option. 5.48 into 10 to the power of minus 7 kg and 9.65 into 10 to the power of 4 coulomb. Generally, as we look at the C is the correct answer, like that we can just go for it. But you see that the unit also, it's very important. So I hope you got a clear idea about, and it is very simple. See, you should use it in a logic way. These are all like memory based questions. Memory based questions only, if you know the tricks and tips and memory part, so automatically you will crack out all those sums clearly. I hope you got a clear idea about this question, and let us go for the next question. Now let us see another important question. 100 ml of KMnO4 solution is exactly reduced by 100 ml of 0.5 m oxalic acid. Under acidic condition, the molarity of KMnO4 is, actually this is completely redox reaction and practical based question. Volumetric analysis you have done in practical, right? Okay, come on, let us find out that molarity of KMnO4. Okay, first and foremost, let us write that equation of redox reaction. KMnO4 plus H2SO4. Why? Because acidic condition plus here oxalic acid, right? COOH, single bond COOH. And you are getting K2SO4 plus MnSO4 plus H2O plus CO. Right? Okay, now balancing equation 2 KMnO4 plus 3 H2O and 5 oxalic acid. You are getting here 2 and here 8 and here 10. Right? Okay, now this is completely redox reaction. Okay, now how to identify the molarity from this equation? Okay, now here the formula generally we use A1 M1 B1 is equal to A2 M2 B2. This all A1 M1 B1 comes under KMnO4. This is belongs to these category. And the same way A2 M2 B2 belongs to oxalic acid H2C2O4. Oxalic acid formula only I have written in a different way. Okay, now what is it A1? Each one we will identify. A1, number of electrons gained per formula unit. Number of electrons gained. Why I have written like this now? Because it is redox reaction, that is what. Okay, number of electrons gained per formula unit. How much? Now, A1 belongs to KMnO4. So, how much electron it is gained for formula unit? It is 5. And the same way, A2. How do we get 5? Because this is gained, right? Okay, A2, it is number of electrons, yes, gained. Here what it has to come? Lost per formula unit, right? Here 2. Okay, now this is M1. M1 is what it is, belongs to KMNO4, no? So M1 equal to, we have to find out. V1. V1 is the KMNO4 solution. It is 100 ml. Right. Okay. Now the same way, A2 we have found out. A2 also we found it. M2. What it is M2? 100 ml of 0.5 m oxalic acid. So it is belongs to oxalic acid. It is 0.5. Right. 0.5. And then V2. What is it V2? Here also 100 ml. Right. Now we found it everything. A1, A2 and M1 we have to find out. M2 we got that. V1 and V2. Now we have to apply the value. Now which one we have to find out? M1 only, no. So M1 equal to A2 M2 V2 by A1 V1. Yes, I hope you got the answer by this time after seeing this formula. Yes, let us apply this. M1 equal to A2, what it is? A2 it is 2 into M2, it is 0.5 into V2 100 ml divided by here A1 5 into this also 100. Right? Okay, now what is the answer here? Can you guess what is the answer? Did you calculate this? Right? Okay, here 0.2 m. I hope you got this option. Which option you got it? Option B. I hope you got a clear idea about this redox reaction. The next very interesting and important question, in which case the number of molecules of water is maximum. They have given the option A, B, C, D, in that which option is having maximum number of water molecules. Okay, the first option A, it is 18 ml of water. So here 18 ml of water, we can consider 18 gram of water. So here number of water molecules. So here 6.023 into 10 to the power of 23. Right? So the option A is this one. Now option B, 10 to the power of minus 3 mole of water. So here what it is, 10 to the power of minus 3 into 6.023 into 10 to the power of 23. So what is the answer you will get it? You will get 6.023 into 10 to the power of 20. Okay, this is option B. Option C. Here 0.0024 liter of water vapor at ATM, 1 atmospheric pressure, and 273 Kelvin. So water vapor, naturally we can utilize this 22.4. Okay, so given mass, that is 0.0024 divided by 22.4 into 6.023 into 10 to the power of 23. So what is the answer you will get it? You will get 6.023 into 10 to the power of 19. You will get it. And option D, 0.818 gram of water. 0.18 gram of water, given mass by molecular mass. Right? So by 18 into 6.023 into 10 to the power of 23. So what is the answer you will gain? 6.023 into 10 to the power of 21. Okay, now you just check it which is that having maximum number of water molecules. Okay, now option A, B, C, D. Okay, now option A, B, C, D, this is 21, 19, 20, 23. So 23, it is having a maximum number of water molecules. That is option A, 18 ml of water, that is equivalent to 18 gram of water, that is having that highest maximum number of water molecules, whereas this and all 20, 19, 21. Yes, of course, which is the correct option? This is the correct option. Okay, hope you got a clear idea about all these important questions, and thanks for watching.